All right, let's look at this problem called house robber 2. We have done this house robber 1 problem, and let's see. And I recommend if we just have a look at that as well. But okay, let's have a read at this one. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All the houses at this place are arranged in a circle. Okay, that means that the first houses are neighboring of the last one. Meanwhile, adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so the house number one problem essentially was the houses in a straight line. The first and the last house were unconnected. That's the only difference between house number one and house number two, where the first and the last guy is also connected. And essentially, you can't rob two adjacent houses. So now you can't rob first and the last house because they are connected, and so on and so forth. So let's look at these examples to maybe make it more clear. All right. So the first example that is given to us is 2 comma 3 comma 2. So it's 2 comma 3 comma 2. Let's also mention the indexes. So 0, 1, 2 are indexes, and these are the money that is present in each and every house. Now, because there are three houses, you can, so zeros neighbor is 1, zeros, and because first and last also connected, 2 is connected to 0, and 0 is connected to 1, 1 and 2 are connected, right? So all like this. So both 1 and 2 are zeros neighbor, both 0 and 2 are ones neighbor, both 0 and 1 are two's neighbor. So you can only rob one house, whichever is the biggest house, you just rob that. So you'll rob this and return 3. Let's do the second example. So the second example that's given to us is 1 comma 2 comma 3 comma 1, and let's mention the indexes 0, 1, 2, 3. So we can imagine these two are adjacent, these two are adjacent, these two are adjacent, and because they're in a cycle, these two are adjacent as well. So you can't drop 0 and 3 together. That's the additional condition. Like there was always a condition that, hey, you can't drop 0 and 1, you can't drop 1 and 2 together, you can drop 2 and 3. Now the extra condition that has come out about is you can also drop 0 and 3. So when that was not the case, well, first of all, so here what do you do? Here the best way is you rob house this and house this, and you get the maximum result as 4. In general, the idea was if you're saying uh, money I, and money I represents max money if I is the last house, right? Then the simple way was uh, there was two options. One is you don't rob this ith house, in which case how much ever money you accumulated so far by the previous house, or you rob this house. So whatever cash is there in that house now, and how much ever money you accumulated, like not the previous, but the previous to previous, right? Money of I minus 2. You can imagine that being the case. And you could use this in the house robber one problem, and come up a solution, come up with a solution for that, right? But now in this, there is a possibility that you robbed first and the last house as well. How do you eliminate that? Like, how do you add that extra condition, right? So that's something we have to think about. So the extra condition, so if your houses are 0, 1, 2, 3, 4, 5, whatever, up till and so on, let's say till n minus 1 and n, if these were your houses, or rather actually it would just be till n minus 1. Um, so how do you handle, like what do you do that the to handle this condition of 0 and 1 not being together? Well, a simple way would be just divided into two questions, right? One is, well, okay, so I take 0, 1, 2, 5 till n minus 2, right? Basically, in one of the cases, I am removing this. In another case, I can potentially remove this. So the second case then would be take 1, 2, 3, 5, n minus 2, and n minus 1. So basically, it becomes the same as house over one problem. You first solve for 0 to n minus 2. Like you remove, basically in your problem, you remove one of the house from the start, or one of the house, the first, either you remove the first house or you remove the second house and solve, and whatever answer you get out of both these two, just give the max of that. It's as simple as that, right? So let's quickly come to the code and use this approach to solve this problem. So we are given house robs. Uh, let's add this utility function called, we'll do this, return uh, whatever max we can get out of, if the nums were there from 0 to nums dot length minus 1. So I'm giving L and R specifically. So this I'll give L minus 2. And this I'll call, let's say, a rob function where you give the array and you give this L and R. So that's one. And the other option is you rob the same houses array, but starting from index 1 till the last nums dot length minus 1, right? And let's implement this function. So you have int rob, you get your integer array, and you have your lnr. That is it. Now you need the last two things. So you need, let's say, um, let's define this as previous as 0 and current as, how many houses can be there? Let's first check that. The number of, so if this only works if there are at least two houses. If there is just one house, so if nums.land equals to 1, I just say return nums of 0, right? Just for, otherwise we'll do this, because otherwise this would be a problem, right? Nums of are, you could potentially do this if so L would be 0 and R would be 0 minus 2, which would be like, sorry, 1 minus 2 minus 1. So if R is less than L, you could potentially just return 0, right? And that would sort of handle this, so then you wouldn't need this explicitly. Fair enough. So you go previous as 0 and current as nums of L. Now you'll do equals to 1, not 1, L plus 1 rather. I is less than equals to R, I plus plus. And you do, so you get a new, let's call it new current. So there are two options, right? Like you said earlier, either you don't rob, in which case it will remain as this, or you rob, then in which case it will becomes nums of I, and you're gonna do what? Previous is current and current is new current, and eventually you will return current. Yeah, that's it. Let's run. Okay, all accepted. Let's submit. And you got a wrong answer for the specific case where you had a single element, and we did handle, and that's probably the only case that failed. But like, why did it not work here? Your output was 0 and your expected is 1. Let's see uh, why these couldn't handle that. Well, yeah, it won't be able to handle because uh, this is a problematic condition, because for this you will return 0, and for this, well, yeah, so I think just handle that case separately. So if nums.land equals to 1, you just return um, you just return nums of I, which is nums of 0, right? Let's also consider the case where there are two nodes. So if there are two houses, then length will be 2. So 0 to 0 would be fine, and this would be 1 to 1, right? So both fine, 0 to 0 and 1 to 1. This array just won't work. So the current would be the initial value and current is what you will return. So I think that should be fine. Let's submit and it works. All right.